one bar stats for me on your data, please, if you would. Run one bar stats. Trey, how you busted out the variation in that. Like you said earlier, it was wonderful, absolutely wonderful. Let's see that, okay? I'll do it with you guys. Here's what I get. So, you get the same thing? We get common results from our data? Excellent. We got 28 data points. What's that? Average. On average, we've been to 17 and a half states-ish, 17 states. Where does that live in our overriding discussion of what we've been doing in this class? Where does that live? Is it a measure of center, variation, or relative position? We've been calling it a measure of center. Can you remind me why we've been calling it a measure of center? This is about 17 states. Why have we been calling that a measure of center? Who wants to give me a nice conversational explanation of what an average is? And I always like to preface this by, assume you're out, it's a beautiful day for yard work. You're out this weekend doing yard work, your neighbor comes over and says, you know, I just read that I shouldn't drink coffee because if I drink more than 28 cups of coffee a week, it increases my chance of early death. Which I just read that about 3 weeks ago. Crap, and I'm like, who drinks 28 cups of coffee a week? And then I was like, wow, that's 4 quarts of coffee a day. Or excuse me, that's 4 cups of coffee a day. That's not that much if you think about it, especially when a cup of coffee is defined as 8 ounces. And you get one of those Mocha Sweeto A's from Starbucks, which has like 4 or 5 cups of coffee in it by definition. Yeah, exactly. And all of a sudden, oh man, you're early death. Oh no. So how do you explain that to your friend? How do you explain that average from that study? How do you explain it? Or this study here. What does it mean that we average 17 states?
Isn't that the equal disbursement?
Say that again.
Isn't that the equal disbursement?
Yes! If we keep track of all the states that we have visited in this room together, which happens to be, FYI, 488 total states visited. That's what this number is right here. It's kind of a handy number to have up there every once in a while. That's how many states we've all visited. Now, obviously, some of us have been to more than once. Or we've visited one state more than once. Like Oregon, we've all counted that one because we're standing in it right now. I guess Washington and Idaho and probably California, too. But if we equally dispersed the 488 states amongst the 28 people, that means we must have all been to about 17 states. 17.4 if you go down to a decimal. Yes, good. What are some other ways you guys have been thinking about averages? Equal disbursement is probably my favorite. That's just, it's the definition of what the formula implies. What other ways have you been talking about equal disbursement or average in general? That's it? That's okay. If you're going to remember one, I'd rather you remember that one, honestly. Equal disbursement. Take the data and spread it equally. Is that a fair representation of the data, if you say it that way? What do you guys think? Is it fair to say we've been to 17 states? That's a good average? Yeah? Okay. Totally fine. There's not a right or wrong answer for this, FYI. Yes? Yes? Who says no? Who says no? It ignores some stuff. Maybe it ignores some stuff? Okay, you guys say no, Linda, tell me why no. No, don't pick on me. I raise my hand, let me call him. Shelly, go ahead. I disagree. Okay, that's totally fine too. What do you think? How come 17 is incomplete in your opinion?
Outliers?
Oh,
Extremes?
are there outliers? Are there extremes? What is extreme? How do you measure extreme?
About two more than two.
2 standard deviations. It sounds like Zach's talking about this guy right here. This guy right here, about 11 states. I'm getting a sample standard deviation of about 11 states. So now, this is why I personally believe that you should never ever separate those two things. I've hammered this into your heads multiple times. They should be paired together. You should never give an average without a standard deviation. Or a margin of error, if you want to talk about it that way, a margin of error, standard deviation. Something along those lines. You need to reference that idea because 17 by itself gives you no idea of how dispersed the data is. That begins to tell you how dispersed it is. That's quite a disbursement if you think about it. Because that's one standard deviation. Zach, if we go out 2 from 17, think about this now. We're making an assumption by doing this, aren't we? That the data is Bell-shaped. If we use the 2 standard deviations, we're assuming it's bell-shaped. If you go out 2 of these, that's 22 states. 22 down from 17 is negative, so we can just go down to 0 and call it good. And 22 up from 17 is 40, 39. That covers almost the entire range of states. It's like, wow, that's kind of crazy. That's crazy wide, yeah? So it begins to tell you that maybe assuming we've all each been to 17 states is a little too wide a net to be casting. We lose that individual variability of each person, the 5, the 48, the 45, the 16, the 4. No, right. So that's why we started, and we actually, did we graph this last time? Did we graph our data last class? I think we did. I'm going to get up there real quick. On histogram L1, beautiful. Yep. And I think we ended up messing with this, yes? We finagled a little bit. We'll go 0 to 50. 5. We like 5 or 10, I forget. We'll go 5. Was it 5? Yep. And then we looked at this and said, oh, this is interesting. It looks like we've got like kind of a leaning bell curve here and then boom, boom, these goofy outliers over there. And we started saying, you know, maybe the 2 standard deviation thing, we got to nix that because it's not really bell-shaped enough. Now, I'm not saying you can't say that it is, Brady, because you can say that it is. There's a lot of gray in this subject. But the question is, are there other ways we can talk about this rather than what's called roughly absolute position? And yes, relative position. Relative position is what we started last time. And one way we did that was using percentile ranking. Why is that relative position and not absolute position? Sarah, I think, has partially answered this with her discussion 10 minutes ago. Why is it relative and not absolute? Relative to what?
Everybody. Population.
Yes, you relative to whatever you're drawing from. It's comparing you and your place within a set of numbers. It's not taking the entire set of numbers and assigning one value to it, and that one value that applies to every single value, like the average does, and the standard deviation does. It essentially lets each data point speak relatively where it lies in line. That kind of make sense? Maybe. If it won't, it will make sense by the end of the day, I promise you that. So the idea is, we speak about, and the beauty of this, rather than we talk about why we do it, or how we do it, why we do it is, it doesn't matter if the data is bell-shaped or not. You can discuss percentages. There's this percent below me, there's this percent above me. What's interesting is, as you analyze this, you get some idea of skew. Percentile rank, how many of you guys ever used percentile ranks or had them used to you? Yes, how many nursing students we got in here? Yeah, nope, it's the same to the raise your hands, yes, because the TEAS exam. Perfect example. You guys still take the TEAS exam for nursing? Yeah, no, yes, no, yes, no, I guess it depends on the school, yes. Their score, I think you have to get in a certain percentile, I believe. Correct me if I'm wrong on this one. No? You just get your score as a percentile?
Yeah.
You get your score, well, yeah, you get your score.
Good, that's excellent. So suppose, Rob, 95th percentile, you score. What does that mean? You tap yourself on the chest?
Yeah, top 10%.
You gotta be top 5%, right? 95 percentile. Top 5%, yes. Now here's the thing, and here's the thing that can be misleading about percentiles. Suppose that exam was 0 to 100 points. Rob, you got a 2 out of 100 on that exam. Suppose Rob got a 2 out of 100. 4 people got 4s out of 100 on that exam. Everybody else got 1s out of 100 on that exam. What was Rob's percentile score? 95%. Because he beat 95% of the people in the study, right? He got a 2, 4 people got above him, that's 5 people total, the other 95 got below him, 95th percentile. Do I want any of them working on me if I'm in the hospital? Not necessarily. So percentile, I'm kidding, Rob. You can totally work on me if I break my face. Put it back together. But my point is that percentile ranks, sometimes you kind of want to maybe have all of these things together. This will tell you where that middle is, and this will tell you whether or not, or how much credence you should put in that. Because percentile rank, that's an extreme case, of course. It's an extreme case. But it does hide that. For years I taught high school, and I gave this this final exam in my geometry class, in-class timed final, over an entire year. What the hell was wrong with me back in the day? And I graded on a curve, which means you put C in the middle, and the A's on the ends, and F's on the far ends, and B's and D's. We'll analyze this more later on in the class. And the kids, one year, tried to throw a riot because they figured out if we all fail it, we all get C's. Because we all land at the middle with the average. And they tried to incite a riot. Nobody studied. Everybody failed. And I was great. I found out this after the fact. And I'm grading these. I'm like, these kids suck. And then 3 kids went against the other ones and did really well. So now I've got this data set that looks essentially like this. You know? Oh, you can't see my head's in the way. Sorry. You know, you got the kids that failed it, and then you have these little kids out here at the end that did really well. I'm like, what the hell do I do with this? And then I talk to them, and they talk about what they were trying to do. I'm like, that's genius. But it's kind of like shooting the moon in hearts. You got to make sure you do it right, yeah? And you make sure that you communicate well. So, you know, you can backfire, obviously, cool plans like that. Very adorable. It's 10th graders. So cute. So anyway, the point is relative position is a great tool, but maybe not just in isolation. So here's one way that it's used. Can you guys do me a favor? Scroll down. So you ran 1-bar stats, yes? Oh, please. Amy.
I'm curious what you did with your students.
I essentially asked them why they did it, sat down, and created a whole other assessment and had them do it again. Which was a pain in the butt because it was June. And I'm like, well, you're all coming in next week. You have 1 week of summer school. And this is the kind of crap you could do at a small private school in Delaware. You can actually pull that off. Everybody's watching. You remember that? Good times. Yeah, they're all like 28 years old now. What's that? Oh no, it was great because it's like one of those head scratch things. Like, what do I fail everybody?
Yeah.
That felt terrible doing that. So I had to create some other assessment. And then it ended up falling into exactly, they didn't do much better, but they did better. It was June, for God's sake. It was a final exam, which kind of planted the seed in my mind of maybe final exams aren't a good idea. And then 20 years later, here I am talking to you guys about assessment. So anyway, 1-bar stats, yes? So here it is. What I'd like you guys to do is scroll down. Take that arrow down. Scroll down. I haven't thought about that in years. It's so funny, Amy. I haven't thought about that result in years, so I triggered that memory today. So when you go down, you get, well, this is still there, but then you get this. You get this. Now some of those, you know what they are, yes? You roughly know what those are. Well, you know what this is. So there's your 15, Sarah, even though you said you were because you were at 16, technically the mathematical median is between 14 and 16, which is 15. So what percentile is this, friends?
50.
That's the 50th percentile. Now the way you write that, you can write that in words, the 50th percentile. But there's also shorthand for it that's used sometimes, capital P sub 50. You can decide what you'd rather. Doesn't matter to me. Doesn't matter to me. 50th percentile. That is the number that chops the bottom half of the data from the top half of the data, by definition. You call it the median. What's cool about the median is it kind of lives in both the center and the relative position world. Because it can. And this is, again, more of that gray area I mentioned before. Everything's absolute in this class. Lots of gray, lots of sliding. What do you think this guy is? Oh, please, Sean, go.
In your percentile notation, that way with just the...
Yes. Yeah, capital P and then the percentile is a subscript. Yes, sir. Absolutely. Who's this? Not who personally, but what is this? Min X would be the smallest data value. What would you call that as a percentile if you had to attribute a percentile to it?
1.
If you had to attribute a percentile to it, what do you think?
0.
0? I go for 0? 10? 5? I heard a bunch of numbers. You guys are giving me very small numbers. I love this. You're getting the idea. It's very, very small. In this case, there was one smallest data value, yes? Let's go back to the definition of percentile. Definition of percentile.
Would be the 1.
What percent are you bigger than? If you are the smallest data value, you are bigger than no one. Therefore, you are the 0th percentile by definition, yes? 0th by definition. It doesn't matter how big or small your data set is. You can see how ridiculous this gets if you have a data set of size 1. If you're a data set of size 1, you're pretty much everything, which is silly. That's why we don't want data sets of size 1 very often. So, generally, you can get away with calling that the 0th percentile, although very rarely will you see the 0th percentile listed anywhere, because it usually isn't called that. It's usually just called the minimum of the data set. I'm just trying to put it in language that we're already using. So, Max, 48, Shaylee, here you are over here. You were the largest data point. Your percentile by calculation was what?
96.
96? Remember she was the 96th percentile yesterday? Which makes perfect sense. With 28 people, each one of us should occupy roughly 3% or 3.5% of the 100%. Suppose we were in a class of 100 people, 100 people, and Shaley still had the most states visited. What percentile rank would she be then?
100.
She'd be the 99th, wouldn't she? Because she's bigger than everybody except herself. So 99th percentile. Suppose we're in a class of 1,000 people, and Shaley is still the highest data point. What would she be then? 99.9th percentile, right? I'm doing my math right in my head, 99.9%. Suppose we're in a class of 10,000 people, Shaley's the highest data point, 0.9999, 99.99th percentile. So you can get away statistically with calling this the what? You can technically call that the 100th percentile if you want to. Now, Shaley, we know that's not right on small data sets. You're actually the 96th or 97th percentile. But in general, I'm going to put a squiggly equals here, only because I see this in the articles all the time. Has anybody ever seen a score from a standardized test that says the 100th percentile? You won't. You'll very often see 99.99th percentile and so forth. So that's why I put squiggly equals. You can't ever get to the 100th percentile because then you'd have to beat everybody else and yourself. And you can't do that. You can't do better than you yourself did. It's like a meta question at that point. But you can conversationally say it's the 100th percentile because it's the max data point. It's fair enough? Okay, great. So that explains these three. What the hell are these? Q1.
Quadrant.
Close. So Omar used the quad prefix, quad, which means, we've used that before in other applications, right? You get a quadricep muscle. Why is it called a quadricep muscle? Because there's 4 muscles in that group. Same reason you got a bicep, 2 muscles in that group, tricep, 3 muscles in that group, quadricep, 4 muscles. Quart, similar to quad, quart. Why quart? 4, oh good, 4 cups in a quart, 4 quarts in a gallon. Good, very good. So quad usually means 4. Oh, blind. So what is, let's go on now. What is that? Well, it's called a quartile. Q1. This guy right here, just so you can see this before I write to the board. That's called the first quartile. This guy right here. This is called, or the lower, first or lower quartile. Lower or first quartile. Please!
Does that have anything to do with the standard deviation?
Nothing, actually.
Okay.
Believe it or not, very good question. Very good question, but nothing to do with standard deviation. Completely removed from it, believe it or not.
Okay.
I'm not saying you can't get an idea of variation from it, because you can. But in itself has nothing to do with the calculation. But what is it? Please, Zach.
It's the average between the minimum and the median.
Can you use a different word besides average? See, what Zach just said is almost 100% correct. He said it's the average between the min and the median. It's not the average, it's the median between the median and the min. Now, that sounds a little confusing. It's like you just said median twice. I did. Say it a different way. What percentile is it?
25th.
It's the 25th percentile. It takes, remember how, when we were doing Sarah's calculation, we had all the data out, all 28 data points. It was so tight. We took all 28 data points, and then we chopped them in half, 14 and 14, and we said the halfway points of the median. These guys take those 2 half sections and cut them in half, and make the percentiles there. So it's the 11 states. This will make more sense with a picture in a minute. I'm just giving you the definitions right now. We'll get a picture up soon, please.
So that's always going to be the 25th
Yes.
percentile, no matter what.
That's my definition is what it is. So using that same logic, this will make a lot more sense with a picture. I'll put up on the board here soon before break. It's before break. Using that logic, this is the 3rd quartile, also called the upper quartile. Yes, you guys are already on this.
75.
Which would be the 75th percentile. You guys are awesome. Why did we skip the 2nd quartile?
Because that's the median.
Because that's the median. Nobody calls it the 2nd quartile. They call it the median. It's a more conversation. I don't know why. Just call it the median. Where's the 0th quartile? We usually call it the min. Where's the 4th quartile? Usually call it the max. So the ones that are conversationally discussed usually are the lower and upper quartiles, which separate the bottom and top halves into, if you will, halves. I'm doing that in quotes because it's not exactly half. So what I want to do is, I want to look at your data again, and I want to identify these parts on them, okay? Is that okay with you guys? Because what I did was I used Excel to make a nice box plot up here. Let's pull it up here. Is there any questions so far before we go any further, as far as definitions go?
You said, okay,
Go ahead, Kelly, please.
so it's the first one is the distance between the median and the.
This guy here?
Yeah,
It's not the distance.
No,
It separates how, you know what, hold that question, give me 5 minutes on that question.
Okay.
3, 2 minutes. I promise we'll get that question answered. Because what I don't want you to confuse is, I don't want you to confuse distance, which is an average measure, with position, which is a positional measure. Remember, when you're talking about placing things in order, it doesn't matter how far apart the numerical values are to each other. An outlier doesn't really exist with positional notation. Because if this one's 10 and this one's a million, this is just the next bigger one from the 10. If from an average point of view, it would drive the average way up. But from a relative point of view, no difference at all. We'll adjust that with a picture in a second. Please!
Will relative position always be percentile?
That's percentiles, quartiles, deciles are sometimes used. We'll come back to that. Octiles are sometimes used. Basically, it's all based on 100% chopped up into pieces. Yes, exactly. I'm going to show you guys a fun graph after the break based on deciles. We'll come back, or quintiles. We'll come back to that. Let's look at your data again. Okay, here we go. Now, I don't think you can do this. Maybe you can on your TIs, but it looks better in Excel, so I'm going to do it in Excel. Turn this off. Turn this on. Please answer that question, Cody.
Do you get the quartiles even if you don't sort the?
Yes, you do. Cody asked the question, did we have to run the sorting mechanism on a TI before we got the quartiles? No. It will quartile and sort unsorted data for you automatically as part of its program. Good question, very good question. All right, let me do this real quick. I want to make sure you guys can see what's going on here. Is that visible? It's almost visible.
So would there be any way to be able to get to the 50th percentile just from that, since that's 20%?
Yes, absolutely. Hold that thought, Cody. Let's get to it right now. Yeah, you got a very good question. 75%. I want to make sure it fits the camera and it fits the screen. Okay, this is not bad. So, what this is, it's a histogram, but it's a dot plot. If you think about it, it's a dot plot of our states. Remember a dot plot from way back in the day when I asked you guys to think of them from 1 to 4? And you all said 1, 2, 3, or 4, and I put dots above. I did the same thing. It's a histogram with width of 1 on the bottoms. There should be 28 dots on this. Let's make sure I did it right. This is ridiculous. This is why we invented Excel, right? Equals sum of all these counts down here. 28. Jeez. Excel's a great thing, especially when you use it. Okay, so here's our data. Can you find the min? Clearly, it's 5 right there. 5 right there. There's your min. So there's Q0, if you will. Q0. I'll give you your question here, Kelly. It's fantastic. Can you find the max? Yes, it's way over here, 48. There's Q4. Also, 100th percentile, 97th technically, but 100th percentile, 0th percentile. Can you find the median? Yes, he's 15 technically, so technically this is Q2. Who asked me about the variation? That was such a good question. Is it tied to variation? You can see why it's not now. You see the distance here and the distance here, the differences? That's because the data is highly skewed. The same number of data points exists here as exists here, but here they're spread much further apart. This is Kelly's question. This is your question. I think it's your question anyway. So, can you find the quartiles now? Well, Q1, I believe, was 11. And Q3, I forgot now. But look, don't tell me. Let's find it. Let's find it. First of all, know why that's 11. There are 28 total data points. Yes, friends? How many are there to the left of the median then? 14. This number has to divide them into two equal pieces of 7 and 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's the divider. You with me? That makes sense? So all I did was I took 28 and cut it into 7, 7, 7, and 7, and these are the cuts that cut them into 7, 7, 7, and 7. Between 5 and 11, that's where 7 of the data points live. Between 11 and 15, that's where the next 7 live. Let's get the next 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I think that's Q3. Right there. 22. Does that make sense? That's Q3. Now I called it Q2. It's actually the median. So somebody said 40. Let me address that question, please. It doesn't always work this prettily. Because 28 divides by 4 evenly. What if we had 29? Well, then it would be a little messier, but you'd still get essentially in the exact same places. The idea is you've cut the data set up into 4 equal pieces, but it doesn't talk about the variation, just where the data is. The lowest, what percent of the data is here? The lowest, 25%. The next highest, 20. Well, the next highest 25, or in total 50. Yes, good. Here, the next highest, and here, the highest, 25%. What these numbers are called is the 5-number summary. That's the colloquial phrase for it, is the 5-number summary. And the reason they're so nice is they give you a really, really nice picture of the data. Now, unfortunately, the picture, much like we can talk about Alaska being the biggest state, but until you slap it on the continental United States, you don't realize how big it is. This might surprise some people. That's how big Alaska is. If you actually drop it on the contiguous 48, this pisses me off. And I'm not from Alaska, I'm from Delaware, which is that. But if you look at most maps, Alaska is tiny. They fit it in the corner. No, you make every map look like this, damn it. Alaska's huge. It stretches from LA to like whatever town that is. I think if you tilt it up, it stretches from LA to New York City, I think. Massive. Much in that same way. Much in that same way. This is a great display, having the dot plot there. But there's something called a box plot, which, let's do it at the break. Let's do it after the break. There's a graph you can add to this that really drives it home even more. But let's not do it. Let's not rush it for 2 minutes. Let's take our 5 and then add it to this display right here. Please, Cody.
I was going to say that it's not actually proportional in all the maps because since the Earth isn't flat.
That's true. You get some, right, but not to the extent they make it that small. It's ludicrous.
Well, yeah, that's if you want the United States that's big on your state, on your map, then you have to make everything else smaller around it.
No, I'm not doubting that you do. I'm saying it's disproportionate.
Yeah.
Criminally disproportionate. Hawaii's too big. Not to slam Hawaii.
Yeah.
All right, let's take 5. Let's come back.